Now let's take a look at example number 2. Again, our goal here is going to be to try to understand how we can use the idea of z-scores to not only measure rarity, but to also understand when something is not very rare. So let's see what we have here. A test paper without a name on it ends up with a score of 80%. The morning class had a mean of 72% and a standard deviation of 3%. While an afternoon class of students had an average of 92% on an exam and a standard deviation of 7%. And so I have this mystery paper, right? You can imagine maybe, if I'm the instructor and I'm wondering, gosh, well, wait, whose paper is this? Then how could I maybe determine which class the test paper is more typical of? Which one is it more representative of, the morning class or the afternoon class? Well, again, since I'm interested in measuring whether something here is more typical, that would be kind of related to a z-score that indicates that I have something that is not very rare. That is something that's between negative 1.5 and 1.5, or as close to 0 as possible. Because, of course, if a value is average, it would be 0 jumps away from average. Its z-score would be 0. And so those would be the most kind of typical scores that we would expect. So let's go ahead and calculate a z-score for each one of these different classes. I'm going to go ahead and calculate a z-score associated with the morning class. So here, if I calculated my z, notice I'd be taking the test paper I want to use. That represents my value of x. I would subtract the morning average of 72 and divide by the value of 3. Now again, you can double check this on a calculator. You should end up with a value of 8 over 3, which simplifies down to 2.6667. And again, remember the units on here are standard deviations. So what we know is that in the morning class, our score is above average by 2.667 standard deviations. So it's starting to get into this actually kind of strong rarity. Okay, well, let's see what the afternoon class is doing. If I take a look at the z-score associated with the afternoon class, again, I have my score of 80. I'm going to have to subtract off the average, which is 92, but I get to divide by 7. So again, I should get something like negative 12 over 7. Well, this is going to give me a value of negative 1.7143. And again, units on here are always standard deviations. That's always the units for z-scores. Now, when I look at this value, I can see that, well, I'm kind of in this moderate rarity range, right? I don't really have either of these values where this is not very rare at all. However, since I'm interested in just determining which class the test paper is more typical of, I can think in which class is this test paper less rare or the least rare. And so it seems that the exam would then be more typical in the afternoon class, since that's only moderate rarity, whereas in the morning class, I'm starting to get towards strong or very strong rarity. So I would go ahead and say that the exam is more typical of the afternoon class. And specifically, the reason why, again, we're measuring this is because, or the reason that we reach this conclusion is because the associated z-score is closer to 0, right? Because 0, again, would represent exactly average. So this is an interesting way, again, that I can use z-scores to help measure, again, the position of an individual data value, that is this test score of 80%. And so we've seen that now we can use z-scores to measure rarity as well as things not being so rare. Now, one final question that we'll have about z-scores is, do we ultimately think that z-scores are going to be resistant? That is, will they kind of stay reliable when really, really large or really, really small numbers end up in the data set? And if you think about the way that a z-score is calculated, remember that we're always calculating it here with a mean and a standard deviation, right? 92 was a mean, 7 was a standard deviation down here as well. And so were means and standard deviations resistant? And we can hopefully recall the answer to that was no. So since my z-score, since a z-score is built from means and standard deviations, it is not resistant. There's no way it could be resistant because the mean and the standard deviation aren't resistant. So what we'll see again is that that creates a small problem. When are z-scores probably the most reliable? Well, they're most reliable if I'm working with a bell-shaped or symmetrical distribution. So what do I do if I don't have one of those distributions? Well, we'll discuss that with a new measurement of position in the next video.